Mr. Moore's math class!
Good afternoon, good morning, good night. It doesn't matter what time of day it is. This is Mr. Moore's online maths class. I'm helping out today because Mr. Moore is on holidays and he's too lazy to get off the couch.
You're spot on, Jerry, man. I told you I want holidays. Let me just chill out on the couch. I want to, look at Facebook and all that kind of thing. Just leave me alone for a bit and let me put my feet up.
Doesn't matter though, guys. I'm here to help out. I'm going to introduce today's topic. It's about differentiating by rule. Enjoy, learn, let's go.
That's right, guys. As Jerry said, I'm too lazy to get off the couch today because, hey, I figure I'm on holidays, I should be able to put my feet up too. And you guys get to learn from the comfort of your own couch, so why can't I teach from there as well? Anyway, as everyone always says, if you can't bring the teacher to the classroom, bring the classroom to the teacher. Alright, you got me there. No one else has ever said that, but it's still something that we can roll with, I think. Anyway, we've got plenty to get through today. We're going to learn all about differentiating by rule. Now, by the end of this lesson, you're going to end up hating that chicken that taught you last lesson because it's going to make everything you learnt last lesson a whole lot easier. So how about it? Let's get stuck into the very first rule. Let's go.
Alright, now this question says find the derivative of y equals x squared. Now if we think back to what we were doing last lesson, what we had to do is first of all substitute in the x value and we would get f of x, therefore was equal to x squared. And then we substituted x plus h for x, and we got f of x plus h was equal to x plus h squared. When we expand it, we got this value here. Okay, so then what we did was we went through and we substituted into the formula to find the gradient. Now f of x plus h was equal to this function here, and we substituted in for f of x plus h right here. Alright, f of x was equal to this function here, so we substituted in for f of x here. We then simplified, so we did x squared and negative x squared cancelled each other out, so you're left with 2xh plus h squared on top over h. We then factorised, taking the h out as a common factor, bringing it out here, leaving us with h bracket 2x plus h over h. Then of course 2h's cancel out, leaving us with 2x plus h. Now the limit as h approached 0 left us with f dash of x is equal to 2x, so therefore the gradient function was equal to 2x. The good news is that I am now going to show you how to do this in a much faster and easier way. Differentiating by rule. Rule number 1. If f of x is equal to x to the power of n, then f dash of x is equal to n times x to the power of n minus 1. Okay, so what this means is I've just called this function f of x is equal to x squared. What we in fact do is we just go f dash of x is equal to, bring the 2 out the front, multiply it by the x, and then do 2 subtract 1, bring the power down by 1. So it leaves us with 2x, 2 to the power of 1 is 1, and of course we don't need to write the 1 above the x. Note here that our answer is exactly the same as what we got before, but in a much easier and faster way. The question in fact doesn't actually ask for f of x though, it actually says for y. So you've got y is equal to x squared. Now when we differentiate y, it's just a little bit different, and that is when we differentiate y and not a function like f of x, you go dy over dx, there's a change in y over change in x, is equal to, multiply the 2 out the front, 2x and drop the power by 1 to the power of 1, which you don't need to write. So it's exactly the same thing, but you write the change in y over the change in x, or the change in whatever pronumeral it is here over the change in whatever pronumeral it is here. Note that d equals change in. This is also symbolised by a triangle, or delta.
Now it's time for rule number 2.
So rule number 2 when differentiating by rule is if f of x is equal to a times x to the power of n, then f dash of x, or the gradient function, is equal to n times a times x to the power of n minus 1. Alright, let's just go through that. I've got f of x is equal to 3x to the power of 5, and g is equal to 2m to the power of 7. Then what I get is f dash of x is equal to 5 times 3 gets us 15. X to the power of 5 minus 1, drop the power by 1, gets us 4. So 15x to the power of 4. And for g, what we do is we do the change in g, dg, over the change in m, dm. Right, noting that the dependent variable always goes on top. Equals 7 times 2 is 14. M to the power of 7 minus 1 is 6. So drop the power by 1.
And now it's time for rule number 3, and in Spanish, rulio, numberio, 3io.
Okay, so the third rule to be aware of when differentiating by rule is if f of x is equal to c, then f dash of x is equal to 0, where c is a constant. So for example, if you have f of x is equal to 7, or b is equal to 6, then f dashed of x is going to be equal to 0, or db on d, we'll call it x, is equal to 0. Because there's no power for x, and if you multiply that by 0, you end up with an answer of 0. So in order to get a value, this must have an x next to it. So when you differentiate a constant, you end up with a gradient of 0, as can be seen for both of these equations.
Whoa. Alright guys, I know it's a dry lesson, but let's stick with it. Just one more rule to go, so let's have a look at rule number 4.
And then finally, rule number 4 is if f of x equals g of x plus h of x, then f dash of x is equal to g dash of x plus h dash of x. Or the gradient function of f of x is equal to the gradient function of g of x plus the gradient function of h of x. So what this means is if you have f of x is equal to 3x squared plus 5x to the power of 7 plus 4, and y is equal to 7x cubed minus 2x to the power of 3 minus 6, then you get f dash of x is equal to 3 times 2 is 6, drop the power by 1, which gets us 1, and we don't need to write the 1 there, plus 5 times 7 is 35, x, drop the power by 1, gets us 6, and when we differentiate a constant, we just get 0, so we don't need to write anything there. For this one here, we're talking y's and x's, so you get dy over dx is equal to 7 times 3 is 21, x, drop the power by 1, so 3 minus 1 is 2, minus 2 times 3 is 6, x, drop the power by 1, gets us down to 2. Once again, we've got a constant here, so when we differentiate that, we just get 0, don't need to write anything.
Alright, so let's put our skills to the test and try some harder questions.
Alright, so here's some more challenging questions to differentiate. So for example, let's have a look at A. So f of x is equal to x to the power of negative 3. Therefore, f dash of x, or the gradient function, is equal to negative 3x, drop the power by 1, and you end up getting to the power of negative 4. This one here, the equation y equals 1 over x to the power of 7. What we need to do first of all is rearrange this. So we go y is equal to x to the power of negative 7, because remember, you can just move that up and change the power to negative 7. Write out the gradient function now, so you get dy over dx is equal to negative 7, x to the power of, drop this by 1, so negative 7 minus 1 is negative 8. And because it was given to us with a positive power, we need to write it back in a positive power. Therefore, we get dy over dx is equal to negative 7 over x to the power of 8. Right, we've got d of m is equal to m to the power of 1/3. Therefore, d dash of m is equal to 1/3 times m to the power of 1/3 minus 1, which is equal to 1/3 m to the power of negative 2/3. Alright, let's write this with a positive power now, so you end up getting 1 over 3m to the power of 2/3. This question here, what we need to do is move the a up, so you're going to write b is equal to 3 over a to the power of 1/2. Therefore, b is equal to 3 times a to the power of negative 1/2. Differentiating now, you get change in b, db, over change in a, dA, is equal to negative 1/2 times 3 is negative 3 on 2, times a, negative 1/2 minus 1 is negative 3 on 2, so you end up getting negative 3a, negative 3 on 2 over 2. Change it back to a positive power now, so you get negative 3 over 2a to the power of 3 on 2, and write it now as a surd because that's how it was given to us in its original form, so you get negative 3 over 2 square root a to the power of 3. Finally, the last question says t of s is equal to negative 2s, bracket s squared minus 3, close bracket. Therefore, we need to expand that first of all, so t of s is equal to negative 2s cubed plus 6s. Therefore, t dash of s, or the gradient function, is equal to negative 2 times 3 is negative 6s, drop the power by 1 gets us 2, plus 6 times s to the power of 1, so 1 times 6 is 6. Drop the power, leaves us with a constant value of 6. And we'll do one more harder question now. G of x is equal to 4x cubed plus 3x squared over x. Find g dash of x. Alright, so let's write out the function. G of x is equal to 4x cubed plus 3x squared over x. Factorise the numerator by taking out a highest common factor of x squared. So you got x squared 4x plus 3 over x. Cancel down the fraction by taking away a factor of x. So you get x bracket 4x plus 3. Expand, so you get g of x is equal to 4x squared plus 3x. Now to find g dash of x, we do 2 times 4 is 8. X, drop the power of 2 by 1, so it gets us down to 1. Plus 1 times 3 is 3. Drop the power by 1, just ends up with no x. So g dash of x is equal to 8x plus 3, where x cannot equal 0, because you can't have x equals 0 up the top here, because you can't divide by 0.